Okay, hello. My name is Aditya Akbar. Here, I want to explain for the safety case on the maintenance chiller for the subject in my university. It is environmental, occupational health, and safety. On the safety case, we rely on bow tie diagram, and bow tie diagram consists um, two barriers to prevent the problems, which is from hazard. It will cause to deviation, penyimpangan. But after that, we have the first barrier, and the first barrier we have will have two results, which is regain control or loss even. If we get the regain control, it will be so fine. But if we lead to the loss even, so we have to go through the second barrier, which is mitigative safeguard. And the mitigative safeguard also have two results too, which is mitigated and unmitigated. So we will take a look on my case, which is maintenance system, maintenance chillers. For this one, the hazard that we can find is that we can find is components are still electrified, and second, high pressure on the refrigerant system. So the deviation would be touching components that are still electrified, that is dangerous, and opening refrigerant system that's still on high pressure, that also dangerous. So the threat, I can write it down, is like doing maintenance without cutting the electric power. And the second is potential direct contact with skin or eyes for the refrigerant with the employee. And the last event is exposure to pressurized refrigerant or electric shock on active mechanical parts during maintenance. So we have the first barrier, which is preventive safeguard. The first is ensuring electricity off, that is a must. And second, opening the refrigerant valve system to release pressure. And the third is wearing standard safety device protection for the employee before doing the maintenance. And from all of it, the actual main procedure is like shut down the system and then venting. Venting is like opening the valve system to release the pressure and then verify if the pressure is zero. So then we will get the result. If we get the if we get the regain control, it will be like the chiller is on safe mode and there is no refrigerant burst. But if we find out that preventive safeguard it is not runs well, we will definitely go to the last event, and the system still active, dangerous for employee, and refrigerant burst to the employee and pollute the area. This one it will be happen if the preventive safeguard is not um, apply apply on procedure. So after we go to the loss event, we still have the second barrier to do. The second barrier is mitigative safeguard. The first is emergency aqueous. We have to have emergency aqueous. It is vinegar solution for cleaning direct contact with refrigerant. It's like for the skin or um, the skin or the clothes that contact with the refrigerant. And secondly, we have first aid. We have to have first aid. It is helping the employee to It is helping the employee to reduce the early stages wound. And the third is refrigeran sensor detection. So if the mitigative safeguard are runs well, it will lead to the mitigated. And the first, there is no serious injury. Second, only there is minor injury. It's like skin burn, small wound by the electric shock. And the third is alarm. The alarm inform all the employee for the refrigerant leakage. But if the mitigative safeguard is not doing properly, it will lead to the unmitigated. First is severe injury will be appear, and many many employees exposed to the refrigerant leakage. It would be so dangerous if like all of the employees get exposed by the refrigerant leakage. So the possible result after deviation is preventive success. We get again the we regain the control again. So all of the system are safe. And the second, preventive is failed, and then loss even happen. But the mitigative is success. So there was refrigerant leakage, minor injury, electricity, personnel were quickly handled. There's no serious casualties on it. And the third is when preventive failed, loss even happened, and mitigative failed. So there was um, refrigerant leakage, alarm sensor malfunction, burn skin field, severe injury electricity, respi respiratory disorder, and downtime on the maintenance section. So that's the case on maintenance chiller, on the maintenance chillers. This is the case that I elaborate from the place that I'm working on. It's just like an elaborate and approximation. If there is something happen, what 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 should we do and what should we prevent to do? What the preventive things that we have to do and mitigation things that we have to do. This is just an elaboration from the place that I'm working out. And the source that supporting my explanation here is here. So that thank you for your listening, and if you have any suggestion, you can comment below. Thank you.